Hey, what's up, guys? In this video, we're gonna evaluate the limits to the infinity of this whole polynomial here. Okay. Okay. Let us start here. As x approaches infinity, x to the power 4 also approach infinity. And the coefficient in front will make the number even larger. Okay, and this one, so we will have here, so we're gonna have here this one tending to the infinity, this whole thing here tending to the infinity, this whole term tending to the infinity. Okay, and x to the power 2 also tend to the infinity, and 8x tend also to the infinity. So we will have the result would be infinity minus infinity minus infinity, and this is not to this is and what is it called, an undeterminate form. Okay, so this is an undeterminate form, so we can give the limit at this stage. So what we're gonna do is try to figure out a way to solve it. Okay, so what if we divided the whole polynomial by the higher power of x, the largest power of x? So it means like we would do the limit x tend to the infinity of x to the power 4 times 2 minus 1 to the x to the power 2. Okay, minus 8 over x to the power 3, 8 over x to the power of 3. Okay, oh, it's looking like a 3x here, x to the power 3. Okay, so now when x tends to the infinity, x to the power 2 is even, still be a large number, so it is an infinity. And when we have a real number over an infinity, of course it tends to 0. So this here is tending to 0. Okay, this one here tends to 0, and that one also tends to 0. So we still have the limit when x tends to the infinity of 2x to the power 4. Okay, that's what we have remaining. And now when x tends to the infinity, of course this tends to the infinity, and times 2, it is the infinity, and our result is the infinity, and that's the limit of this function when x approaches infinity. Okay, so another example, let me just take that example right here. Give another example right here. So let us just write this here like our first example, and the second example is coming here, and it's going to be the limits when x tends to the infinity of 1/3 x of x to the power 5 plus 2x to the power 3 minus x to the power 2 plus x. Okay, and oh, excuse me, it is tending here to minus infinity. Okay, all right, so we're gonna do the same thing. When x tends to the infinity minus infinity, when x tends to the minus infinity, x to the power 5 tends to the infinity, and this is an odd number, so it's going to tend to minus infinity, and this one is tending also to minus infinity because of the odd power. and this one is turning to infinity, and this one here to minus infinity. So we're still gonna have an indeterminate form. I'm just gonna call it indeterminate form, if. Okay, so we're gonna do the same thing just like we did before. Limits. Okay, we will factor the power, the larger power, and then the larger x power. Okay, x2 tends to minus infinity, so the largest power here is x to the 5 times remains here 1/3 plus 2 over x to the power of 2, of course, minus 1 over x to the power 3 plus 1 over x to the power of 4. Okay, and just like we did before, when x tends to the infinity minus infinity, the whole thing here 2 over infinity, it could also be minus or plus, tends to 0. Okay, this tends to 0, this one here tends to 0, and that one there tends to 0. Okay, so we still have the limit when x tends to minus infinity of 1/3 x to the power of 5. Okay, as you can see, x tends to the infinity because we have an odd number here. Okay, anytime you raise a negative number, you raise a negative number to an odd power, it still be negative. So we're gonna have the whole thing here tending to minus infinity. So our last result will be minus infinity. Okay, and that's our result for the second example. Or the solution to that question, to those two exercises. Okay, guys, thank you for watching again, and until next time, bye bye.